Now, if I'm looking for the sum of a geometric series, probably if I have this, I'm looking for the sum of this geometric series, where n is equals to 0, and it tends from 0 to infinity for a series like this a(r) raised to power n. As usual for our geometric expression, a is a first term and r is a common ratio. So that Sn from this point will be the same thing as ar raised to power 0 starting from 0 plus the next term ar raised to power 1 plus ar raised to power 2 plus it continues this way until infinity. Now let's multiply this equation by r. We'll multiply this equation by r and let's call this our equation 1. Now if we multiply equation 1 by r, it becomes r Sn is equals to a, because ar times r becomes, that's r plus 1, that's a, plus ar raised to power 2 plus ar raised to power 3 plus, and it continues to what? To infinity. In what infinity means it has no end. Let's call this equation 2. Now we'll be subtracting equation 2 like we did when we solved for the finite geometric series. We'll be subtracting equation 2 once again from equation 1. Now we'll multiply equation 2 by negative. That becomes minus Rsn is equals to minus a. That's minus ar, sorry, this ar, minus ar minus ar squared minus ar raised to power 3 minus up to what? Infinity. Now that means my Sn minus Rsn will be equals to a, which is the first term here, then ar minus ar gives way, ar squared minus ar squared gives way, continues like this. Here you should have ar raised to power 3 minus ar raised to power 3 gives way, continues that way up to what? Infinity, and infinity gives way, each of them gives way. So I'm left with Sn minus r Sn is equals to a. Now let's factorize. Sn comes out, I have 1 minus r is equals to a. So that Sn will be equals to a over 1 minus r. Now this is a formula to find the infinite sum of a geometric series. Let's take a good example. If I have a geometric series such that my first term in the geometric series is 3, and I have a common ratio, let's say we have a common ratio of 2 over 5. Now the secret to it is this: anytime you have a common ratio that is less than 1, and greater than minus 1, it must always lead to an infinite geometric series if it is not terminated. If it's terminated, take for example, if I want to terminate the series at probably the 5th term, then I'll be terminating at the 5th term. But if I don't terminate it, it will definitely continue. Now for this geometric series where my first term is 3 and my r is equal to 2 over 5, my second term, as first term is 3, the second term will be 3 times 2 over 5. So that my second term will be equal to 6 over 5. Then my third term will be the same thing as 6 times 2 over 5. That's 12 over 25. The fourth term will be 12 over 25 times 2 over 5. That's the fourth term. That will be 24 over 125. Now my fifth term will be 24 over 125 times 2 over 5. That will be, my fifth term will be, that's 48 over 625. Now this geometric progression or geometric series will continue this way until you get to what? Infinity. Now, but we can find the sum of this geometric term, so that with Sn is equals to a over 1 minus r, we'll be saying that this is equals to a. My a here is going to be 3 over 1 minus 2 over 5, which is equals to 3 over 1 minus 2 over 5 is written as 3 over 5, which is equals to 3 times 5 over 3. 3 here is 1, 3 here is 1, which is equals to 5. So that the sum, with this we can conclude that the sum of this geometric This infinite geometric series is the same thing as 5. Thank you and do have a nice time.